Thank you very much, Chuck. Again, my name is Tom Popik. I'm chairman of the Foundation for Resilient Societies. We're a nonprofit group that is concerned with protection of critical infrastructure. There are several of us that have been here at this conference. We're going to be talking today about energy security impacts on the data center industry. I'd also like to introduce my fellow panelists, Dr. George Baker, who is also a member of our foundation, and Mike Caruso. So our agenda briefly is I'm going to talk about some things that we learned from going to a data center conference. Now, in order that we get EMP protection for the grid, we're going to need some industrial constituency. We need some people who make money, who are dependent on the grid, who are going to be advocating for this protection. So it's nice for us to get together, but we need the industry deep pockets. So we decided we'd reach out to them and go to the big data center industry conference, which is held in Orlando this fall. So I'm going to be reporting back on some of what we found out by doing that. I also should say we didn't just go, we were actually general session speakers. So it was Dr. Baker, John Kappeman, and myself. So we got to speak to the whole conference, and people came up to us. We learned quite a bit. I'll also be briefly going through some of the official government reports. We've had a lot of experts talking about threats to the grid, but there's also a government consensus that I'll be briefly reviewing. Then Dr. Baker is going to be going through a presentation about some specific threats to data centers. He actually has the incredible advantage of having consulted to the data center industry, so he brings a lot of knowledge. And then we're going to have Mike Caruso from ETS-Lindgren. He also has real-world experience with the data center industry. So we hope to give you a view of what's happening in industry. And let's just think about data centers for a minute. I'll go through some of the critical sectors that are very dependent on data centers. So we can start with the electric grid, right? We can move on to telecommunications. Telecommunications increasingly is dependent on data centers, so these big switching centers are actually filled with computer servers. We had a presentation on healthcare earlier today with a captain from Northcom. Well, medical records now are contained in data centers. Let's think about the Department of Defense. That's run on data centers too. So you can see how the data center industry aspects that we're going to be talking about today really go across many of these critical infrastructures. So these are some of the issues for data center operators. I'm going to tell you some complaints that they have with power quality issues as well as grid reliability. I'll give you a statistic. In the United States, the typical customer experiences one grid outage per year. So some of you may not have experienced one outage per year, and what that means is there's other people that are unfortunate that experience more than one grid outage. Amazing statistic, the average outage is about 200 minutes, and that's a long time. And again, many of us don't experience outages of that duration, but others that are less fortunate do. It turns out that the United States actually ranks pretty far down the list in terms of electric grid reliability. So we're behind many of the European countries in reliability of our grid. It's interesting that when Congress passed the Energy Policy Act in 2005, they only mandated an adequate standard of electric grid reliability, not a good or an excellent, just an adequate standard. So these data centers have to deal with this unreliable electric power, also poor quality. They experience issues such as flicker, that's when the lights flicker, what they call voltage sag, harmonic distortion. We've heard presentations about how when there's these solar storms that can cause incredible harmonic distortion, the data centers have to deal with that. How do they do it? Well, it's expensive for them. They install very large uninterruptible power supplies that have batteries, and then the batteries typically only last about 15 minutes for a data center. They're only designed to be a bridge until the diesel generators can kick in. Now the problem with diesel generators, first of all, they're not reliable all the time. So there's a range of reliability. One statistic I've heard for nuclear power plants, their diesel generators are about 99% reliable. So they'll start up about 99% of the time. And they have redundant generators, and so if you do the math, the chance that 2 or 3 won't start up is quite small. But on the upper bound, a statistic I've heard is, for example, a hospital or something like that, the generators wouldn't work about 30% of the time. So think about that. Also, these diesel generators are hard to maintain because they're hard to test. You have to get environmental permits just to test the diesel generators. So you don't use the equipment every day. It may not work when you need it. A big issue, there's only a few hours or days of on-site fuel for diesel generators. It's hard to store the fuel. It tends to age. You even get mold growing in the fuel, or you get water condensing in the fuel. There's a process called fuel polishing where companies will come out and clean up your fuel for you. But I think it's appropriate to say that sometimes you may be dealing with contaminated fuel in a crisis. Well, Hurricane Sandy showed some of the problems with these backup diesel generators for data centers. The data centers, there was a hospital in New York City. Their diesel generators didn't go on. There was a data center also in New York. They actually had to have a bucket brigade with diesel fuel to resupply it. There were instances where the fuel trucks couldn't get through. So the data center industry is getting really frustrated with this situation. Many of them don't have backup sites that are far afield that would be outside the outage area. A lot of times the backup sites are within, say, an hour's drive, about 60 miles or so. That would be within the same control area. The data center industry is now starting to clue in that you might have to be in a different control area, or actually even in a different interconnection, as it's called. What is the data center industry doing? Well, they've tried to complain to their utilities for decades now and haven't made a lot of progress. Increasingly, they're moving to their own generation. So data centers are now installing hydrogen fuel cells to go off the grid. These hydrogen fuel cells operate through natural gas. It turns out the natural gas system is more reliable than the electric grid in many cases. So that's a little bit of a summary of the situation with data centers. I'm now going to just briefly go through some of these official U.S. government reports. Well, let's start out with the U.S. Department of Energy and the North American Electric Reliability Corporation. They came out with a report, High Impact, Low Frequency Event Risk to the North American Bulk Power System. These high impact, low frequency events, we've been talking about those all day. So even the people who are supposedly protect the reliability of the grid recognized the threat. They've backed off a little bit, I think, on some of the conclusions in this report. Then we have the National Academy of Sciences National Research Council. They produced a report in 2007. It was interesting, Department of Homeland Security, when the report was finished, classified it. The authors of the report were very persistent, and in 2012 they succeeded in getting most of the report declassified. So now we can read it. We know the title, Terrorism and the Electric Power Delivery System. It's interesting. What it essentially says is if there was a physical attack on the bulk power system, we could be without power for days, weeks, months, even years. The U.S. Government Accountability Office has done some excellent work on the threat of cyber attack. The U.S. House of Representatives realizes that there's a problem with how electric grid reliability is regulated. I'll read a couple of the conclusions from this report because I think they're particularly pertinent. Most utilities have not taken concrete steps to reduce the vulnerability of the grid to geomagnetic storms, and most utilities do not own spare transformers. Isn't that interesting? Oh, and if you look up a little bit, You can see more than a dozen utilities reported daily, constant, or frequent attempted cyber attacks. There's a report from the Department of Energy that talks about the difficulty of replacing transformers that have been damaged in a physical attack, and also talks about how these transformers, for the most part, are not manufactured here in the United States. The vast majority are manufactured overseas. Here is a picture that shows the difficulty of replacing these large transformers. They can weigh up to 400 tons. They require special railway cars or special trucks. You see here that the overhead power lines sometimes have to be moved. It can take weeks to get one of these transformers transported to a location and replaced. And think about what would happen if an area was without power during that time. Oak Ridge National Laboratory has produced a number of excellent reports on geomagnetic storms, on nuclear EMP. I should say all these reports are publicly available. They're on the internet. Anybody can read them. This one authored by John Kappeman, Geomagnetic Storms and Their Impacts on the U.S. Power Grid. We have another report about radio frequency weapons, authored by William Radasky and Edward Savage. This is a lot of the analytic framework behind some of the EMP protective measures that we've been hearing about today. And the really big significant study by the Congressional EMP Commission talking about the threat of nuclear electromagnetic pulse, which could be a countrywide phenomena. So look at all these government reports, and we've had experts here. I think that the experts we've had are credible, but these government reports are really, I would say, indisputable in terms of a societal consensus that we have a very significant problem. For those of you who want to read some of the reports on your own, we've provided some hyperlinks here. And so if you get an electronic copy of our presentation, you'll be able to just click through and take a look at these reports. So now I'm going to go ahead and transition to Dr. Baker.
So I want to talk about big data center protection challenges. So I'm the protection approach, and then I'll be followed. We'll get into some details there at the end. I didn't say at the. I was very disappointed Kevin Briggs couldn't be here, because a lot of what we're talking about in the previous session and this session, he's right in the middle of it, and I saw his intended presentation. It was a good one on the FirstNet and some of the challenges, and hopefully he'll get permission to present it on the next go-round. So just again, here's what I want to cover. Illustration. This is a Oliphant cartoon I thought is very instructive, where the lights go out and they realize the computers don't work. Computers are shut down. Somebody finds a flashlight, and they advise you need to write a message, and they don't know what write means, because they're computer guys. And so the bottom line is we're doomed. Okay. Well, this is what we want to avoid, and the good message is, we're not SOL. There's lots of things we can do. This, we can avoid this kind of situation. So the migration to cloud computing has put more and more eggs in a smaller number of data center baskets, and people are migrating to larger and larger and larger data centers. And I've been to data centers where I'll say, well, where's your backup power? And they'll say, well, we don't need it, because if our site goes down, we've got another site, say 200 miles away that will fail over there, and we've got automatic failover, logic circuit failover. And then I say, yeah, but the EMP footprint is 1,000 miles, so it's going to take out not just you, but your failover site, and one of these. So this is a problem we need to watch very carefully. The EMP RF weapon technology is diffused. I have a friend who got a Walmart vinyl briefcase and built one that burned out his own computer with it. He cut the antenna out of tin foil and used a fluorescent light starter for his power supply, and it cost the parts cost $200. So it just isn't one example. Inadequacy of operational response procedures. We need to protect. You need to put in the physical protection. You're not going to have time to respond. Sorry. And then just general lack of awareness is a problem. So one of the things we're trying to do is we give these presentations to the data center community and the electric power community, just create awareness so people will know what embarrassing questions to ask their representatives and their power industry commissioners. Okay. Oh, yeah, I'm not going to dwell on this, but just basic EMP characteristics. We've already seen this in a previous talk, the power spectrum and the area coverage is the big problem. But notice that the EMP frequency spectrum only goes up to a gigahertz down here. And you have both E1 and E3. E3 is the very low frequency effect there. Now, with RF weapons, there is a picture of a couple of them. This is the one on the right looks like the one that my cohort just recently built. But the environment effects are comparable to EMP E1, except that you're going up to 10 gigahertz. The thing is, with the RF weapons, the energy falls off as R squared, so the effective range is much more limited than with the EMP, where you're getting thousands of miles. There are a lot of people who, they think, yeah, you need to protect against RF weapons, but they don't see the RF weapons as an existential threat. You're not going to get the entire continent simultaneously like you would with the nuclear. Okay. And so if you look at this, here's the frequency band. You can see the RF weapons are up there in the gigahertz range. Actually, we found that they're very effective down to 10 megahertz. That's actually the RF weapon envelope there should go down to 10 megahertz. And here's a notional chart of the range to effect versus weight. For the lower curve is damaged, the upper curve is upset. And this is based upon a scalable ultra-wideband device that we developed. And it's not all inclusive, but it just gives you notionally how much weight it takes. If you want kilometers of range, you're talking about mounting things on trucks. The briefcases will have effective ranges of around a meter. Now this is just I tried to put on one chart the combined effects here. You've got the EMP E3 and the geomagnetic disturbance in the first column there, the fast EMP E1 on the second column, then RF vulnerability. And you can compare and contrast their system effects so that the grid power transmission distribution, the EMP is the most effective. The RF weapons can take out the control systems, so that is a worry. But I don't think the RF weapons will take out the big transformers. And you can just look down the list there. The asterisk means that those systems are vulnerable to harmonics. There are certain things that will happen in the data centers due to E3 because of the harmonic distortion on the power grid. But there you have it, just sort of a compare and contrast all these different effects. We know how to protect. I won't dwell on this because I talked about this in the previous presentation. But we know how to protect data centers. We've been doing it, and I should also mention this is the protection approach that will be used for the FirstNet. And we know that the protection is affordable. We've been doing it, but you'd like to have the protection included in the system design, not as a retrofit. And then the other big important thing that we stress when we talk to the data center owners, talking, Microsoft and Google and, Facebook, these companies have data centers. You need to really disperse your backup failover sites, if possible, on different continents. And in many cases, they actually have their failover sites over on the Pacific Rim, so that's good. But if you have all your failover sites in the continental United States, you could be in a world of hurt. Okay. And I'll stop there.
We're going to continue to go for a few minutes, even though we're like over time. So if you could do it about 5 minutes roughly. I know it's a little tighter than what you expected, but it's okay because we'll take some out of my time after Andrea. We won't take time out of her slot, but we'll just start a few minutes late. Go ahead.
Okay, I'll go quickly here anyway. I'm Mike Caruso. I'm with ETS-Lindgren. We are a company that deals primarily in the passive control of RF energy. We've been around for about 50 years. I've been in the business about 31 years, and as Dr. Baker had talked about earlier, for DoD, for the past 30 years, I've been involved in protecting military and government sites from HEMP. What we've noticed lately, over the past 2 years, is a very high increase in data centers looking to do EMP protection. And we found that to be very interesting. So talk a little bit about it. The data centers are opting for the global protection, as Dr. Baker was talking about in his last presentation. And yeah, wrong way. No, going the wrong way. Sorry about that. Let's see, this was part of your presentation still. Okay, there we go. Talking about data centers, this is something that's very interesting, and these are standards that are put out by the Uptime Institute, people that are heavily involved in data center evaluation and maintenance. A Tier 3 data center, which is more likely than not having some backup power and some backup capabilities. The allowable downtime per year is 1.6 hours. So that falls into the realm of the 200 minutes that you were talking about. However, there are Tier 4 data centers, and those Tier 4 data centers primarily service financial industry and insurance and some of the very critical infrastructure component elements that exist. Downtime for that is 2.4 minutes per year. That's the acceptable downtime. So it's something important to remember that for the data centers, we're looking at protecting not only the power grid, but protecting the data center itself. The equipment within the data center is quite vulnerable. This is yet another example of a truck-mounted device. Tens of thousands of volts per meter that it can produce. Put the cover on the truck and drive it around and turn off the lights. So the data centers are not only aware of the EMP threat, but they're keenly aware of the IEMI threat, the intentional electromagnetic interference threat. And the IEMI is the term that the IEEE has adopted to talk about the high power electromagnetic interference that would be created by a weapon, an RF weapon type device. This is kind of a sobering slide because it tells you the vulnerability of the standard equipment. Standard IT equipment, according to global harmonized standards for electromagnetic compatibility, only gets tested to 10 volts per meter. After that, it's vulnerable. And we're talking about thousands and tens of thousands of volts per meter in an EMP event or an IEMI attack from a truck-borne device. But even a suitcase-mounted device can exceed the 10 volts per meter. So if someone were to enter a data center or get close to proximity to your equipment, at 10 volts per meter, it could interrupt it, probably not destroy it with a suitcase device. But going down the list, medical equipment we talked about before, 10 volts per meter. Telephone network equipment, 10 volts per meter. Aircraft cockpit controls, 7,200 volts per meter. We far exceed that with EMP. Automobiles, they're a little bit more stringent, but they're 100 volts per meter. That's tops on them. And for military equipment, we go to mil standard 461, 464. 200 volts per meter is the outside testing that happens on military equipment if it's not EMP hardened. This is just a depiction of a data center being protected. And looking at the data center, when I'm talking to data center people, I'm talking to them about two modes of protection. This I'm talking about survival mode. In this mode, we just would go ahead and put a shielded enclosure in place. All the points of entry would be protected. The communications would be fiber optics. All of the precautions would be taken, but there would be no backup systems. So this, in a co-location data center, it would be sitting there. If the power went down, if the cooling went down, this data center would go down in an event. However, the equipment within the data center would stay protected and be able to be restarted when the services were brought back. The second mode of protection is actually providing a secondary shelter that houses backup power and backup cooling systems and the cooling plants that gets interconnected with the data center, and this is for survival and continuous operation. Many of the financial institutions that I'm talking to on a regular basis are opting for continuous operation because offline they can lose millions of dollars per minute. And as Tom was talking about, you take this to an economic level. You take this to basically buying insurance for their continuing operations, their disaster planning, their disaster recovery. And this is where it starts to make a lot of sense for these operations. For protecting an entire building, the added cost for the building alone, not including the equipment that might go in that building, but you're looking at about a 15% premium to go in and put the protection in and design it in up front as a new installation. If you're looking at a retrofit, then that cost is going to rise somewhere between 20 to 30% as a retrofit because you've got to go in and do a lot of moving around. Remembering that on data centers, key is power and cooling. When protecting data centers, we've got big old water chillers sitting out on the roof. We've got generators outside. We've got racks of communications equipment. All of that needs to be protected. So again, it's not just the power grid. So we've been talking about protecting power grid here, but we're talking about protecting critical infrastructure users with the data centers. And it's becoming more and more important and a significant part of looking at the overall protection of the critical infrastructure. So with that, I'm finished a little early.
Very good. Thank you very much. While Andrea's coming up, we have one question as Andrea comes up, and what we're going to do is take more questions at the end. And any questions right now in the front? Do I see a hand? Do I see a hand? No hands? Oh, man. That's because you gave such a wonderful presentation and have their head spinning. But it's really important as you're thinking about microgrids and how do you protect them and the controls and everything you have from. It's very much like protecting data centers. It's almost having like a little data center.
I'd like to clarify something. The 2 to 5% I quoted was for the total system cost. The 15% was just the building. It turns out the best data I've seen is once you build a building, the cost of the electronics in these data center is 8 times the building cost. Yeah.
Yes, and yeah.
By the way, just as sort of an announcement, this is a fun thing, and it ties to data center hotels or telecom hotels.